Right, so in this clip we're going to work through the first 8 questions in this intermediate tier paper 1 numeracy exam from November 2016. Pretty much what you need to be aiming to do here is to score maximum marks in these first 8 questions, because beyond that the topics that are covered are predominantly grade B standard questions. So you're really looking to concentrate and focus and maximize your marks on these questions. So, question 1. Marcus is a farmer. He has his own conversion graph to change between acres and square yards. So both of those are units of area. Square yards would be an imperial measure and acres would be a metric measure. And what I suggest you do with the table or a graph or anything like that is work out what the graph is telling you. So what this is saying is, if you have 1 square acre, that's equivalent to reading across your graph to 4,840 square yards. Or if you had 9,680 square yards, that would be equivalent to 2 acres, and so on. Complete each of the following statements. 3 acres is equal to blank square yards. Well, you can see here that the problem is the graph doesn't go up as far as 3 acres. So what you need to do is think, well, what can I take off this graph that I can read, and then by increasing it, by scaling it up, get to 3. So what I'm looking at here is 1, 2, 3. That's going to be 1.5. So if I can read off what 1.5 acres is, by doubling that, it'll give me 3 acres. So in order to do this, that's 1.5. So if I read up to 1.5, I can see clearly that that's 7,260 square yards. So 1.5 acre is 7,260 square yards. So if I double this, I get 3 acres, which means I have to double that as well. So non-calculator paper, so I'm showing what I'm doing. 2 times 0 is 0, 2 6s are 12, 2 don't carry 1, 2 2s are 4, and 1 is 5, 2 7s are 14. 14250 square yards. 14520 square yards. So I've shown my workings, I've shown it on the graph. It's right or wrong, but you want to make sure it's right, so put your workings down. Now for 5.5 acres, again that is off the graph. So what you want to do is think, right, well, what else have I got to do? I know what 3 acres is. So if I can take other values off here to work out what that would be, but if I know what 3 acres is, I can add on to that another 1.5. which would give me 4.5, and add another 1. So that would give me 3, 4, 5, 5.5 acres. 3 I've worked out is 14520. 1.5 is 7260, and 1 is 4840. And again, this is a non-calculator paper, so somehow I've got to perform that addition. And there's no real space here, so what I'd be tempted to do would be go to the extra room for extra workings on the back page and do my workings out there. I haven't really got room to do that, so what I'm going to do is work it out here. So I've got 1 4520, 7260, 4840. Am I going to add those together? 0, 6 and 4 is 10, and 2 is 12. 1, 9, 10, 11, 16. 1, 5, 12, 16. 1 and 1 is 2. So we've got 2, 6, 6, 2, 0 there, and that there. So for this question, 1 mark for that, right or wrong. For this, there's 1 method mark for showing how you're going to get what you're going to combine to add up to give you 5.5. There's other ways of doing it. You could have, you know what 3 acres is, so you could double that to make 6 and subtract half an acre. Lots of different ways of doing it. The most common mistake I saw when marking work was that people were reading this first dot off as 1 acre and using 2420 as an equivalent for 1 acre, where it's not, it's a half. Okay, question 2. So this is the question where how you lay out your work and communicate what you're doing will credit you an additional 2 marks. As you'll see when we work through it, that doesn't mean you have to write a story. It just needs to be clear that you're showing what you're doing. So Roland's going to buy some orange juice for a party. Which size bottle of orange juice offers the best value for money? So here are our bottles. Small bottle 300 millilitres for 66 pence, medium 400 for 92 pence, and large 500 ml for £1.25. Now when you are looking or working with value for money questions, what you try to do, or what you aim to do, is to have an equivalent cost for a comparable quantity of liquid. So we can't multiply those up. Well, you could, but you'd have to end up going quite far. But what they want you to do, or what you want to think about doing, is saying, right, well, if I know 300 mils costs that, how much would 100 milliliter cost? How much would 100 milliliters of this cost? How much would 100 milliliters of that cost? So the way that we do that, if we work with a small bottle, 100 milliliters, or if we start with 300 milliliters, costs us 66 pence. If we divide that by 3, that'll give us 100 milliliters. And if I divide the volume by 3, I have to divide the cost by 3 as well. 66 divided by 3 is 22 pence. So each 100 milliliters of small costs 22 pence. Then we do the same thing with medium, where we have 400 milliliters costing 92p. So we've got to divide that by 4 to give us the 100 milliliters. When we divide 92 by 4, half it again. If you'd rather do bus stop, we could do that. 4 into 9 goes twice. 2 4s are 8, remainder 1. 4 into 12 goes 3, so it's 23. So you either do 92, half it, 46, half it again, 23, or you go for a non-calculated division. It doesn't matter. So the medium bottle comes to that, and then the large bottle, 500 ml, £1.25 or 125 pence. Divide by 5 to get 100. You've got to divide that by 5. Let's go bus stop again. 5 into 1 doesn't go, so you move on to the next one. 5 into 12 goes twice, 2 5s are 10, remainder 2, 5 into 25 goes 5 times. So 100 millilitre of the large costs 25 pence. So as far as best value for money is concerned, the large is costing you the most for every 100 litres, the medium is costing less, but the least is the small bottle. So that's the small bottle best value. Now there are 3 marks for that. The arithmetic marks are for comparing ideally 100 millilitres. You could do it other ways, but it's more complicated. So the 3 marks are for getting the 100, 22, 123, 125, clearly showing your method and then coming up with the correct conclusion. And then the additional marks for organisation and communication is just by saying, well, that calculation is from my small bottle and I'm working with 100 millilitres, medium, large, and again drawing the conclusion. My units are consistent. I got millilitres and I got pence or pounds, whatever I'm working with, so the units are all correct as well. Galena needs to buy exactly 800 millilitres of orange juice. What is the best option for Galena? You must show you're working and consider all options. And you must give a reason for your choice. So what we have to do here for 800 millilitres is look at what different combinations of bottle will generate 800 millilitres. And it's exactly, so we're not going to say 2 large bottles because that's over. So we're looking for combinations that will add up to 800. So we could have 2 medium bottles. And they'll cost 2 lots of 92, £1.84. Or we could take a large and a small. And that's going to be 66 plus £1.25. 1, 6, 7, 8, 9, which would be £1.91. So the best option would be 2 medium bottles because they're going to cost less. Will save her 7 pence. Difference between £1.91 and £1.84. So for the 3 marks there, you need to show the examiner that you're working out the cost of 2 different combinations and coming up with a conclusion as to which is the best combination. Question 3, surveys. A survey was carried out to find how often teenagers buy DVDs. The following 2 questions were asked in a questionnaire. Question 1, where do you live? Question 2, how often do you buy DVDs? Never, 1 to 10, 10 to 15, more than 15. For each question, give 1 reason why it's not suitable. So there are various different answers you can give for each of these. But the first question there, where do you live? Well, what this survey is trying to carry out is how often teenagers buy DVDs. So you might want a question on how often you buy DVDs. You might want a question on how old you are. You certainly don't need to know where somebody lives. So the issue with question 1 really is it's not relevant. Really doesn't matter where they live as to how often they buy it. And then for the second one, well, there's lots of different issues with this. The most obvious is you have an overlap between this one and this one. If I buy DVDs 10 times, which box do I tick? But you could say it doesn't give you a time frame in there. So is that 1 or 10 times a month? Is it a year? Is it ever? So that's the sort of question, the issue that they're looking for you to pick up on there. Which box do I tick for 10 DVDs? Would be a criticism. No time scale would be another criticism. You only need to give one of those. The survey was carried out by leaving copies of the questionnaire on the DVD shelves in the supermarket. Give one criticism of how the survey was carried out. Well, a number of things you could say there. You could say, well, it's biased because the questionnaire is on the DVD shelves, so clearly it's asking people that buy DVDs. You could say that there's nobody monitoring who's filling them in, so you could have a little granny filling them in, or you could have a 10-year-old child filling them in and you wouldn't know. So things like that is what they're looking for. So I'm saying biased because your audience will be DVD buyers, or no supervision to determine questionnaire is being completed by teenagers. Again, I've given you a couple of examples there. You only need to come up with one. Question 4. The map shows a part of Wales. The position of Newtown is shown on the map. Write down the bearing of Welshpool from Newtown. So the from bit is important because that's telling you where you're standing. So that's telling you where you're going to put your angle measurer. You need to remember that you measure bearings in a clockwise direction from north, when north is 0 degrees. And I've drawn that line through so that I can make it clear when I'm putting my measurer on that I can see clearly where it's crossing the scale. So north 0, outside scale 10, 20, 30, 35, I get that. Now, where you have to be very careful here is if you wrote that down as your answer, you're going to get it wrong because that's an angle. Bearings are 3 figures, and if you've got an angle which is smaller than 100 degrees, you add a 0. So even though you'd correctly measured the angle of 35 degrees or 34, there's a 2 degree margin of error that they'll allow you. Without that 0 in front of it, you wouldn't get that mark. Name the place on the map that is on a bearing of 235 degrees, again from Newtown. So the measure is going back on Newtown. Now I'm going around the outside to 235. 180 would be south. 230 is there. 240 is there. 235 is in between. And we can see that the town is going through is Llangurig. So 2 marks for that. Part C. The distance from Newtown to Welshpool is approximately 14 miles by road. Estimate the distance by road from Welshpool to Llanfair Caerhunion in miles. So the distance from Newtown to Welshpool is approximately 14 miles. So Newtown to Welshpool is that road there, and if we measure just the straight line distance between there, then that's about 4 centimetres. I know the road's a little bit longer, but this is an approximation anyway. So 4 centimetres on the map that we've just measured is roughly 14 miles. And we want to use that information to get from Welshpool to Llanfair Caerhunion. So Welshpool is there, Llanfair Caerhunion is there, which is 2.5 centimetres. So that's N to W. Now I'm going W to, and that's 2.5 centimetres. Okay, so if 4 centimetres is 14 miles, that means 2 centimetres will be half as far, which is 7 miles. I want 2.5 centimetres, so another centimetre on there would be 3.5. So 2.5 is going to be around 8-9 miles. Bit more, bit less, doesn't matter. It's only an estimate. Just checking, anything between 8 and 11 miles is acceptable. So you've got quite a big margin of error there, but this is what they're looking for you to do. So my answer is 9 miles. Megan lives in Caermaes Road. To travel to work, she starts by heading to Machynlleth. So Caermaes Road is there, and she's going in this direction towards Machynlleth. Her journey to work is approximately 40 kilometres. Convert 40 kilometres to miles. So this is one of the relationships that you're expected to know. You're expected to know that 5 miles is roughly 8 kilometres. So 40 kilometres is 5 times as big. I times 8 by 5, I get 40 kilometres. So if that's 5 times as far, that's 5 times as far as well. So what they're looking for there is 25 miles. Now 25 miles, if I know that 4 centimetres is 14 miles and 2 centimetres is 7, that means 6 centimetres is 21. Add another centimetre. If I add those all together, I get 4, 6, 7 centimetres is 10.5, 24.5 miles. So what I need to do is find out for 25 miles roughly how far away, how many centimetres from Caermaes Road is she in that direction. She's not going over there, she's going in this direction. So what town is roughly 7 centimetres from Caermaes Road? And you can see there in that direction the only town it's going to be is Aberystwyth. So marks there, 1 mark for that. Seems you've done quite a lot of work, or we've done quite a lot of work for that. but you have got a margin of error. There's a method mark here for knowing the relationship 5 miles is 8 kilometers and trying to scale it up, and an answer mark for 25 miles, and then 1 mark for working out how far on the map 25 miles is going to look and identifying the town. Part D is a different type of map scale where we've got 1 to 10,000. What this means is that one of whatever unit you wish to measure with on the map is 10,000 times as big of the same unit in real life. So 3 centimeters on the map is going to be 10,000 times 3, which is 30,000 centimeters in real life. If you write down the 30,000 centimeters, you get a mark. What we then have to do is to turn centimeters into meters. So you need to know that 1 centimeter is there are 100 centimeters in a meter. So to divide that, to turn that into meters, we have to divide it by 100. The easiest way when dividing by hundreds and thousands and whatever, where we've got the zeros, is you can divide for every zero on the bottom. What you're doing is dividing by 10, divide by 10, divide by 10, divide by 10, leaving us 300 meters. So there's 2 marks if you get 300 meters. There's 1 mark if I see, or the examiner sees, 30,000 written anywhere. Question 5. Students are taking tests in English and Welsh. The English test is marked out of 80. The Welsh test is marked out of 70. David scores 35 in his English test. So he scored 35 out of 80. Estimate David's score as a percentage. Well, I know that 50% of 80 would be half of it, which is 40. So it's less than 50, so it isn't that one, but it's not much less than half of it, whereas that's quite a lot. So I would be pretty confident that 44% is going to give you the right percentage. Liam scores 22 in his Welsh test, so that's 22 out of 70. Estimate Liam's score as a percentage. Well, half of 70 is 35. So this one's not as easy to see as the one above, because it could be either of those. So what I'd be thinking then is, well, okay, let's find out what 40% of 70 is. 40% of 70, 10% would be 7, 40% would be 4 lots of 7, 28. So that's still quite high. What would 30% be? 30% would be 3 lots of 7, which is 21. I've got 22, so it's a little bit above 21. So I'm confident that 31 is going to be my answer. Rowena states a hypothesis. A hypothesis is just a mathematical statement of likelihood. She thinks boys do better than girls in their English tests. She displays the test marks for 5 girls and 5 boys in scatter diagrams. So what we have here is the girls' results. So for the 5 girls, as far as a relationship is concerned, what you would say is, if the better they do in one, they're likely to do better in the other as well. So if they're good at English, they're good at Welsh. If they're not good at English, they're not good at Welsh. But it doesn't help you compare boys and girls, because that's only girls. And that's the same information for the boys. Does the data support Rowena's hypothesis? So go back to what she's saying. boys do better than girls in their English tests. I'm not interested in their Welsh tests. So let's see how I can get their English marks off here. For the 5 girls, here are their English marks. So one of them scored that value, 10. One of them scored 20. This one scored, and we're looking at the scale here, it's going up on this axis in units, ones. So that's going to be 33 and so on. So I'm going to list those now so that I can compare them. Girls. I've got 10. I've got 20. I'm probably not going to be able to fit them in if I go down. 20. I've got 33. I've got 50. And I've got 70. And now if I do the same for the boys, I've got one scoring 10 in English, one scoring 20, so those are the same, cancel each other out. Then this one scores 35, which is bigger than that one. This one scores 60, which is better than that one. And this one scores 75, which is better than that. So this, what Rowena's hypothesis is saying is that boys do better in English than girls. Well, the data that we've got, that's true. It does support that because they cancel each other out, but in the other 3 the boys do better. So does the data support? Yes, it does support Rowena as 2 boys and girls score the same, but the others, boys, score higher than the girls. Another thing you could do is you could add up those and you could say that the total marks of the boys in English would be higher than the total marks of the girls. That would be absolutely fine. How could Rowena improve the testing of her hypothesis? The common wrong answer here would be to say we'll put all of the information on one graph. But you can't do that easily because you can't plot boys as an axis and girls as an axis. You would just have 2 columns. So what you want to be saying here is to look at more than 5 sets of results. You want to look at more data. 5 pairs of data aren't really very much. So increase the number of test marks you are looking at or you're comparing. Draw by eye a line of best fit. Just find my ruler. To estimate how many marks you might expect a boy to score in a Welsh test if he scored 50 marks in his English test. Now a line of best fit needs to follow the slope of the majority of the of the points. So you wouldn't go for those 3 and ignore those 2. You certainly wouldn't insist it went through 0, 0. You're only really interested in between the 2 extreme points. So we're going to go for something that looks like that. Okay, it could vary slightly, it doesn't matter. And then we're looking for 50 marks. So 50 marks is here. So I'm going up from 50 marks in English to that point there, and then reading that point off the vertical axis. And on this axis, you should be able to see that it's not going up in units, it's going up in twos. We go from 0 to 10 in 5 jumps. So 2, 4, 6, 8, 10. So this is going to be 50, 52, 54, around 54 or 55 marks. So that's important with a line of best fit, that you don't try to join all the dots, you're just looking for a line that follows the general slope of the points that you plotted. So for that, 1 mark for justifying whether Rowena's hypothesis is correct, 1 mark for suggesting increasing the data, 1 mark for drawing the line of best fit, and 1 mark for using the line of best fit to estimate Welsh marks. Question 6. Markin has a market stall to sell his printed t-shirts. Costs him £250 to buy 100 plain t-shirts, 50p to print a design on each, and he sells his printed t-shirts for £4 each. At the start of the week, his bank account balance is £820. He has 100 printed t-shirts ready to sell, and he's already paid for these. During the week, he sells his stock of 100 t-shirts. He pays all the money he takes from selling the t-shirts into his bank account. He then buys and prints another 400 t-shirts, and he does not sell any of these 400 t-shirts. How much will Markin have in his bank account at the end of the week? Now, often with a question like this, where you're given a lot of information, it's helpful to write your answer before you start, so you know what you're aiming for. And obviously we haven't worked out the answer, but what I mean is, what I'm aiming to do here is to answer the question, how much will Markin have in his bank account at the end of the week? So what I want to be able to write at the end of this question is, Markin will have some value in his bank account at the end of the week. So by writing that, I know what I'm looking for. I'm looking for a number in there, which is how much he's got in his bank. Okay, so let's go through what we've got. At the start of the week, he's got £820. And he's got 100 t-shirts ready to sell. And he sells them. So how much money is he going to make for those? He sells his t-shirts for £4 each, so he's selling 100 t-shirts at £4 each. So that's going to generate for him 400 quid, which he's going to put in the bank. So in bank, he has £820 plus the 400 that he's just earned from flogging his t-shirts. £1,220. What he then does is buys and prints another 400 t-shirts. So 400 t-shirts, it costs him £250 to buy 100. So buys 400 tees. So that's going to cost him at 250 for 100. So 400 would cost him 4 lots of 250. Double it, you get 500. Double it again, you get 1,000. So the t-shirts are going to cost him £1,000, but he prints on them as well, and the cost of printing them is 50 pence for each t-shirt. So for each tee, and he's bought 400 of them, well, 50p is half a pound, so 400 half pounds would be 200 quid. So what's coming out of his bank account is 1,200, £1,200. So out of bank is £1,000 plus £200, £1,200. So he's got 1,220 in his account, and he's got 1,200 coming out. So at the end of the week, Markin will have 1,220 less 1,200 equals £20 in his bank account. So what goes into the question mark? £20. So 4 marks. Where are the 4 marks earned? There are 4 marks there. 1 mark is for working out how much he has in his account at the start of the week. There are then 2 marks for the method of the cost of the teas and the cost of printing to get the 1,200. And then there's the remaining marks for working out what the difference is and what's left in the bank account. Question 7. When it is 21:30 on a Tuesday in London, it is 02:30 on a Wednesday in Dhaka, Bangladesh. It takes 10 hours 30 minutes to fly from Dhaka to London. The flight leaves Dhaka on Thursday at 1300 local time. On what day and at what time should this flight arrive in London? So first of all, we can see that Dhaka is ahead in time of London, because that's Tuesday, that's Wednesday. So the first thing then is to work out how much time difference there is. So we're going from 21:30. If we go an hour, another hour, we're now past midnight, another hour, and another hour. 1, 2, 3, 4, 5 hours. So London is 5 hours behind Dhaka. 1 mark for that. I've shown it there. You could have done that on your fingers, however you do it, but it's important you don't guess it. It takes 10 hours 30 minutes. On lots of work I've marked, people missed the 30 minutes and they were only working with 10 hours. The flight leaves Dhaka on Thursday at 1300 local time. So they jump on a plane at 1300 and they're going to fly for 10 hours 30 minutes and land in London. So the way that I would teach this would be to say, as soon as you're on that plane, you're going to change your watch. As soon as you're sitting on a plane, even before you take off, you're thinking London time. So 1300 Dakar time is 5 hours earlier in London. 5 hours, take 5 off 1300, you get 8. So my watch sitting on the plane is now saying 8 o'clock, and I'm going to be sitting on that plane for 10 hours 30 minutes. So I'm going to add on to that 10 hours 30 minutes, and I'm going to get to 18:30 in London. So the time is 18:30, and the day is the same day that we took off, because we've travelled backwards 5 hours in time. So it's still going to be Thursday. So marks for that. 1 mark for recognising the time difference. 1 mark for then working in the right time. So changing it into London, adding the time on, or adding the time on and then taking 5 hours off at the end, whichever you choose to do. And finally, scale diagram opposite. See if I can fit this all on. Scale diagram opposite shows an Eisteddfod camping field. The camping field is 100 meters long and 80 meters wide. So 1 centimeter represents 10 meters. So 100 meters long. So there's my 10 centimeters. Shrunk slightly in printing. So that's its length, and 80 meters wide, that's its width. So that's 100. That's 80. A river runs along the side AB. So AB, river. There's a hedge along AD, AD, hedge. There's a fence along BC, BC, fence. DC is an opening with access to the Eisteddfod camping field. So people can come into the field from that area, that open side of the rectangle. The scale used is 1 centimeter represents 10 meters. A barbecue area is to be built on the camping field. The barbecue area must be nearer to the river than to the opening of the Eisteddfod camping field. And it must be nearer to the river than the hedge, and it must be more than 30 meters from the corner of the field where the hedge meets the river, so that corner. So let's take each of those conditions one at a time. Nearer to the river than the opening. Well, the river is a straight line there, and the opening is a straight line there. So the dividing line between it being nearer and further is halfway. So halfway of 80 is going to be 40, which will be 4 centimeters. So if I measure 4 centimeters there and 4 centimeters there and draw that line in, that line is the boundary. If I'm this side of it, I'm closer to the opening. If I'm this side of it, I'm closer to the river. If I'm standing on it, I'm the equal distance from the two. So I want to be nearer to the river than to the opening. So the barbecue area is on this side somewhere. So I've drawn that boundary. Nearer to the river than to the hedge. Well, the river is that line, and the hedge is this line. So to work out the boundary which makes me stand closer to one of those or the other means I'm going to cut that angle in half. Now, on a numeracy paper, you don't have to construct this. You can just measure it in the same way I measured that. So if I'm cutting an angle in half, I'm going to use this. And because that's a right angle, I know it's 90. So to cut it in half, I want to measure 45 degrees. So I got my 0 there. I'm going up the inside scale. There's 40, there's 50, halfway between 45 degrees. So let's just check this. If I'm standing here, I'm closer to the river than I am the hedge. If I'm standing here, I'm closer to the hedge than I am the river. If I'm standing on the line, I'm the same distance from both. More than 30 meters from the corner of the field where the hedge meets the river. So 30 meters from where the hedge meets the river is corner A. And this now is part of a circle. 30 meters is going to be 3 centimeters given the scale. So I've got my compass point on 0. I've opened the compass to 3. I put my compass on the corner and I draw part of the circle. Let's just check what I'm saying. If I'm standing in there, I'm less than 30 meters from the corner of the field A. If I'm standing out there, I'm more than 30 meters from the corner. If I'm standing on the curve, I'm exactly 30 meters from the corner. So those are my lines. What I've got to do now is work out which part of those lines the barbecue can go in. So go back to the first one. Nearer to the river than the opening. So this is the straight line that's cutting the field in half. I need to be nearer to the river. So I have to be on that side of that boundary. So everything above it, I don't want. So I know that I'm in this half here. Nearer to the river than the hedge. So that's the river hedge boundary. I want to be nearer to the river. So I'm in this part here now, below that line and below that line. And more than 30 meters from the corner of the field where the hedge meets the river. So more than that boundary. That's exactly, that's less, this is more. Which means the barbecue can go anywhere in this region here. If I'm standing in that shaded pit area, I'm closer to the river than the field. I'm closer to the river than the hedge, and I'm further away than 30 meters from the corner where the river meets the hedge. So on a numeracy paper, you don't need to worry about remembering constructions. You need to be able to draw part of a circle, but you haven't got to worry about perpendicular bisectors or anything like that. You can measure. And that's it. Those are the first 8 questions that cover the up to and including C grade questions on the paper.